All right, thanks everyone for joining. Today, I'm going to talk about when I decided to use Druid instead of a data warehouse. And for anyone who doesn't know me, hey there guys, my name is Ben Rogashan. Some of you might know me as the Seattle data guy. You've perhaps seen my YouTube channel or seen my newsletter, but a little bit about my actual day-to-day. My day-to-day involves being an end-to-end data solutions consultant. Essentially, that means I help companies take their raw data and turn it into something that they find valuable, right? That could be a dashboard, an ML model, what it ends up with ranges, but that is my overall goal. I've, at this point, worked in many different industries, everything from finance, insurance, transportation. I've also spent some time when I worked full-time at Meta. And now at this point, I just consult and provide, either a combination of advising or hands-on consulting where I come in and do the actual work. On top of that, I like to say I am an accidental writer and YouTuber. I do put out a lot of content to help people who are trying to understand what is going on in the data infrastructure world, whether that's building data warehouses, working with Druid, working with other solutions. There's a lot of other things that are all coming out and people are all trying to keep up with everything there. And that's really my focus there when it comes to content. So for today, again, really want to focus in on a specific use case, and we're gonna talk about that here in a second. But before diving in there, just a little more in terms of like quick background, in terms of the projects that I tend to take on, because I think that will help just set the groundwork for what to expect, kind of what exactly my focus is, and where Druid came in. So the projects I tend to take on generally, I like to call them your standard data analytics projects, right? Most of them often have some sort of data warehouse component, some sort of ingestion component, something where people, again, want raw data centralized and analyzed. Also, I have a lot of common problems I like to say I come in for, besides your standard cloud migration project. I like to call it the MongoDB problem. Just because it's come up a lot, which is often people trying to do analytics on something like MongoDB versus something that is more built for running analytical queries. So that's often a problem I get brought in for, especially I think when it comes from people on the software side who are trying to build some sort of analytics just into essentially what they already have in place. And often they run into problems, whether it's trying to run queries that aren't really meant for analytics, or just trying to push way too many queries to something from an analytical standpoint that really is meant to be more transactional. And so that's often a problem. Another issue often is what I like to call the key person problem. This often is when someone perhaps built something at a company, maybe they're the only data engineer or the only software engineer. They built some unique data infrastructure and then that person left, and now, again, no one really knows how it was built, how it should be operated, and they need someone to kind of come in, simplify it, build a solution that they can rely on and can easily maintain. And I often say a lot of the times I'm called in, the need is often to be more pragmatic versus clever. I think that's something I view in terms of data engineering in general, whereas most solutions don't necessarily need to be complex, but instead often just need to answer the problem. And it's a combination of just discipline and finding a solution that works for your specific problem. So whenever I start looking into different use cases, different problems, different solutions, that's generally where I'm coming from. I'm not trying to find always the newest solution. I'm trying to find the solution that is the best fit. Whether that is, again, newer, older, there are a myriad of options. And so I like trying to find the things that really fit a end use case. And now in this, again, presentation, I really want to talk about, why in one of these many cases, I've picked Druid, instead of maybe a traditional data warehouse to solve a problem. That's really the focus of today, again, is, why we picked Druid, again, for the specific client, which we'll talk about here in a second. But again, I think that's not always paused on enough. I think people sometimes jump into, this is the standard workflow, right? I want to do a dashboard. I want to perform analytics. Thus, the only solution is often a data warehouse. And I think that's kind of the path many of us take. because it is the obvious answer. It is the one that most of us feel is the solution, especially if you are coming from a data engineering background. But what I often find, again, is there's kind of two different sides to this, where one side tends to be the data engineering mentality, and the other side tends to be the software engineering mentality. Again, in the software side, you'll often find people just build on top of what they've already delivered. So MongoDB, Postgres, and on the data eng side, you're going to find someone building something like a data warehouse. But there are, I think, middle grounds, both in terms of solutions as well in terms of use cases. Like there are cases when maybe a data warehouse is just not built for something that is more in the lines of a borderline application that has an analytical like flavor to it, which is where and why we ended up picking Druid for our specific use case for today. So as I mentioned, again, we're going to talk about one specific use case, and as kind of reference, this specific client had something unique, whereas in many other cases, right, many people want to build a dashboard that maybe gets viewed once every blue moon, once every month, once every week, maybe daily, but the amount of people hitting it are maybe on the lower side, or maybe don't have as much of a need to be in real time. Then it can make more sense for your more standard solutions. But in this case, our client was kind of a mid-size ad tech company, meaning that they're doing hundreds of millions of dollars in terms of revenue, gross revenue a year, and they're spending hundreds of millions of dollars on ads for other companies, right? They're in charge of basically making sure that they get the best bang for the buck, both for obviously themselves, but also for their clients, right? Like how they're placing ads, how they're making sure that the end results that are coming in are both accurate, but also, again, having ROI is very, very important. A lot of companies spend tons of money in marketing, most of which, at least if you look at a lot of studies, often feels like it is wasted. So the more you can prove that your spend is valuable, the better off you'll be. And so this company really likes to prove that, hey, we're not just giving you, engagement. We're not just giving you, your click-through rates. We're honestly doing so much more than that. We're providing you information. We're providing you insights into your data. One of the things that they were dealing with is just the fact that there's a high chance of fraud in ads. Sometimes this is because, especially if you're doing this kind of third-party service where maybe you're helping service ads into blogs and websites, it's a very good chance that maybe there's some level of fraud in there, where maybe a website is trying to fake traffic or something that then costs your customer money, or this customer, their client would lose money. And so they have a high chance of that, and they've got to deal with that in real time. Because again, you can quickly find yourself spending those hundreds of millions way too quickly. But you also want to provide that information so that your customers know how their money is actually being spent. And again, because they have all these external partners, this gives them hundreds, if not occasionally thousands of users that are hitting these dashboards, these fraud applications that they're developing, all of these different layers. And sometimes, again, if you're going to use some more traditional data warehouses, likely they will not hold up to the same level because they are not built to be treated as an application. So this is why we went down the path that we did, which I'm going to go into the next slide and we're going to talk about. This is kind of the basic data infrastructure we ended up developing. The company already had essentially a Snowflake and Tableau instance already set up, right? This was used for, and we'll talk about this here in a second. This was already essentially used for their traditional BI work, but they really were trying to find a solution to handle this more, again, middle case, where it's like, hey, we have an application like use case where we have analytics. We want to run certain bits of business logic ahead of time. We want to be able to take that data. We want to give it as much of a real-time feel as possible. And what can we do to find that solution? As you can kind of see, they already were loading data into HDFS from their MySQL instance, which is essentially where all of their raw data or their application data was living. And so they would then fill that into HDFS, into Parquet files that could then be used later. They had already, again, done a lot of that work, which was kind of great because as we were building the system, it was really easy to constantly test and make sure that whatever data was in system A matched system B. So that was something I found really helpful as I was like building out this overall system. And then we also ended up sitting a superset on top of that to do a lot of the actual analytics. So we kind of kept it a pretty open source stack in this case. And I'll kind of go into why here in a second, but it was a really kind of solid stack for your real-time application. Again, the focus was supporting multiple real-time applications that we were developing that provided or had some sort of analytical side to it. So we didn't just want to do some basic CRUD work. We wanted to do things like, again, fraud detection, calculate spend and earnings based off of different ads, ad campaigns, and different customers, and all of that needed to be done as much in real time because, again, we had hundreds of thousands of users that were actually looking at that information at any given point. So kind of, again, why the two different paths? I think that's a valid question, right? Like we had two different paths. We went through the effort of building essentially two different infrastructures. One that essentially is what I'd consider the more traditional data engineering approach where you're going to put it into a data warehouse, and another where we stored it and read directly from HDFS with Druid essentially sitting on top of that. Druid acted, or Druid was kind of using HDFS as its historical node. So why the two paths? There's honestly a myriad of reasons that we ended up picking or going down this path. Some of the kind of obvious things I think overall that I've already referenced here. One is just the fact that Druid gave us that ability to have that application like feel where we could have, high queries per second hit Druid and fill whatever superset requirements in terms of like actually loading that dashboard very quickly with new data versus having to wait for an ETL process that needs to run and go through, possibly a daily or maybe hourly process with Snowflake. On top of that, I think another thing, and I didn't actually note this down, or I did, is the fact that it was generally more cost effective. The amount of usage that would have been required from Snowflake would have been pretty cost prohibitive in terms of having to have a ton of essentially scaled out nodes for Snowflake. You'd have to have multiple warehouses that would be allowed to scale out. It would become very costly very quickly. So it wasn't necessarily as cost effective to have something that was going to be treated almost more like an application database when it's not geared, I think, towards that from a cost perspective. So I think that that's another aspect. Even if you were to try to scale out Snowflake, it just really isn't built as much for application side type workflows. Whereas Druid was, I think the other thing that was really, really helpful here was they had a very strong engineering team. So we could do a lot of open source work and set up things like, again, Druid, Superset. We didn't have to pay for, again, with the Tableau, we didn't have to pay for a ton of license for viewers. We had a very controlled stack in terms of pay. They were also very much on-prem for these solutions. So all of this made picking Druid a much more appealing solution. And I think that's something that, again, as you're trying to find the right solution for different clients, whether you're a consultant or if you're just a solution architect at your company, there are a ton of other options that don't have to be either on the cloud already or something that is a paid for solution. There are a lot of options that I've found that can be the right choice that maybe don't get referenced as much, right? Like maybe there isn't as much discussion around certain products, but they still have very great use cases that I think sometimes get underutilized. And I think one of them in particular is this, right? Whenever you have something that is real-time application, you need that analytics component. You want to like do pre-aggregation, which we'll talk about here in a second, but you want to do that pre-aggregation. Tools like Druid, I think, have been very helpful for me in terms of like finding a path there that actually makes more sense, again, than something that is more traditional for some people. So that's kind of why we ended up picking this overall infrastructure. Really this gave us the advantage of having data that was more in real time, right? Like we're connecting it straight to the HDFS instance, which was being fed in real time from MySQL. On top of that, as queries were coming in, we easily were able to scale out to the right number of nodes that could handle the hundreds and thousands of users that were querying data. And we could easily feed all of the various superset dashboards that we developed, as well as the fraud detection system we had put together, without worrying about if we had enough warehouses essentially that were existing. We easily were ready for those workloads. So that's kind of why we ended up picking this overall infrastructure in this case. Again, like I think before you take any approach or you pick any set of solutions, it's really important to understand everything from the amount of usage that will happen, what the use cases are, cost. I think it's always a major point that I think needs to be considered. Sometimes doing things on-prem or doing things that are open source do make sense. And that's why I'll always lean towards that when there's a good case for it. But this was kind of, again, the overall end look for our data infrastructure for this client. Cool. So again, we've built this data infrastructure. At the end of the day, you don't want to just build things for the sake of building things. I have one person that likes to say, you shouldn't build things for infrastructure's sake, infrastructure for infrastructure's sake. Tools are all cool. It's cool to say you're using current solutions that maybe are being used by top companies or that are being marketed heavily. But I think it's always important to think about your end user, right? Like I talked about, it's important to think about things from the technical side, so your cost, how things are going to run. But it's also really important to think about how, at the end of the day, your end user perceives and works with the system that you've developed. And so from the user perspective, all of this that we've built really helped answer a lot of problems that they were dealing with, even if they didn't always see it. Again, we've kind of covered the cost-effective aspect, right? It easily scaled. We didn't have to worry about that. The other thing is we built in a lot of the logic that could help pre-aggregate data, which was really important because they were dealing with hundreds of terabytes of data, which when it came down to speed and making sure that they actually could pull the actual bits of data. So when they're populating every dashboard, when they're building essentially views to be viewed on top of it, they wanted to make sure that they're getting the data in a fast enough manner that there were some pre-aggregated data sets that were built in. So that was part of it. And again, this allowed their clients to have access to real-time spend at certain granularities very quickly. And I think that was very important because these clients were spending, again, hundreds of millions of dollars to try to get massive returns. And so they want to know, how are things being spent? How or are campaigns for product X doing well? Are they doing poorly? Are we losing $1 million a day trying to sell a product? Do we need to change now? Do we need to change later? And these aren't things that I think would have been as well supported on the traditional path, where maybe they'd have to wait a day or two to get updated on some of this information. They could see it essentially in real time as things were happening, and they could figure out if the levers they were turning actually made sense, and if they were actually getting the results that they wanted. The other thing that was important is they no longer had this issue in terms of high queries per second. When they were going down the Snowflake route, they were definitely struggling to make sure that they were meeting the needs in terms of speed, in terms of essentially the SLAs that were set by their clients. And so by switching over, they could end up mitigating many of those issues just through Druid and how they set it up to actually scale out as they got more users querying. Obviously there's heavy times, there's slow times, but especially in high peak hours, they were able to kind of handle larger amounts of viewers actually trying to access all of the information that existed for these various dashboards. Again, that's what I think is kind of sometimes missed is, we sometimes forget the end user when we build a solution. Maybe we're more focused on trying to make sure the right things are on our resume, or we want to work with a solution because we want to work with it. I really do think it's important that as you're trying to answer the question of what solution should I pick for this use case, that is an important aspect of it, right? Like you need to answer, does this actually help my users? If speed's important, does it actually give them the speed? If they need to know information live because it could cost them, millions of dollars, that needs to be done. So just important aspects as you're picking out the right solutions and going through all of the myriad of solutions that exist in the data world, I think are important. You don't just want to use the solutions that are written about or have articles. You really want to make sure you find the solutions that fit your need. So that's just always a point I think I like to hammer home as I'm talking through with different users and different people trying to find the right solutions. I do want to cover what made implementing Druid easy. In this case, I think I was very lucky for the company that I was working with. They already were using HDFS, so it was really easy for me to sit essentially Druid on top of what they were already running. That also, again, like I said, made it easy to just QA information. It's very easy just to point back and forth in terms of, do things match report A, report B? We're literally basing it off the same source. So we were very able to just tell and provide that confidence very quickly to end users, which obviously is always very important when you're trying to build these new systems, is you want to make sure you gain confidence from your users very quickly, and you don't want to be spending a ton of time, just having to prove that your systems are right and having to constantly reconcile small numbers. So that was really helpful, not just because they were already using HDFS and it was set up, but because we could just easily pull data directly from there. Again, pre-aggregating data really made things easy. That was a feature that was very helpful in terms of taking all those terabytes of data that did exist and just adding some layers so that some of the tables that we built out in Druid really were manageable. Also, again, on-prem infrastructure being well supported was very, very helpful in this case. Having a DevOps team that can easily spin up, spin down the different nodes that we needed made it very, very easy to find a configuration that worked really well for our use case or our various use cases, so that we could actually support the end users. And so that is what really made this whole process really easy in terms of like Druid being easy to set up, manage for us. So it was great just to have that, and I wanted to call that out because I do think it's important to also think about the talent that you have in terms of like how you're going to set up Druid. If you are going to use it and you're going to manage it yourself, you do want to make sure you have the talent to do it. They are making it easier, but I'll always say make sure you've got the time and the talent to manage any solution you pick, whether that's Snowflake or Tableau or Superset or Druid. Cool. So what was kind of the results? At the end of the day, everything should be outcome driven, not just, we shouldn't just be purely focusing on, again, infrastructure for infrastructure's sake. What the end results were, obviously, is one, we were able to end up detecting several cases of fraud, even while I was working on the product. We had several instances where we noticed some spikes in abnormal activity coming from specific regions, and we were able to essentially immediately mitigate that as in real time as you can get, right? Like as soon as you see it, you have to start making actions and figure out who the right people are to essentially provide that information to, and how to actually track it down, and et cetera. But again, there were several instances where even just mid-building of solutions, we were able to do that. The other thing I want to say is like customer satisfaction overall increased as people got real-time access to data. That just overall brought more usage of it. And I think that's one thing that's always great when it comes with building things like your data warehouse or using Druid. As you're building these solutions, I think it's always great as people have more access to data that they will actually using it. I think that's one of sometimes the hard things to describe is that, some of the use cases that you're going to come up with aren't even going to exist until after you provide other people access it with it, right? Like you're going to have now these customers that have more access to real-time data, probably want more information that they didn't have before. They were making decisions with data set X, and now they have X plus Y, and now they're probably going to want more information, and they're even more engaged with your product. So, making sure you pick the right solutions And giving people reliable data, I think, tends to lead to that. You know, you have people who are even happier with the information that they have and now want to make new decisions and want more information on how they can actually make those decisions. So they're going to ask you, you know, what more can they get? You know, how do they maybe they get more data in real time? How do they add more flavor to this data? And so those are the key results from this project. And I think that's always, again, the outcomes are really the main focus for anyone developing data infrastructure. So, I mean, again, this is kind of me just reiterating the point. Why do we pick Druid? Again, I like to think that I try to always take the time to think what is the right solution for this specific use case or this specific problem, or, you know, broadly for this company. And so there are many reasons you might pick one solution or the other. And in this case, I think Druid made the most sense. I think it was the one that was well supported from the various reasons that we ended up deciding on Druid. Again, just going back to the fact that traditional data warehouses, you know, they're great, but they aren't great for every fit, right? Like, they aren't a perfect thing. They have really specific use cases that I love using them for, but sometimes you have this real-time need to have an analytics application that needs to be fed from something that might be architected a little different to actually handle the scale and larger amounts of queries. And also, again, cost ended up playing a huge role here. When you're at a smaller company, maybe it makes sense to spend, you know, $10,000 a month on a cloud service. But as companies become larger, as your tech teams become larger, you often have the talent or at least the use case that is large enough that, you know, the amount you'd end up spending on many of these solutions end up in the 6 or 7 figure range to do something that, you know, one engineer could probably solve. So cost ended up playing a huge role in this as well. And I think that's often a good factor to consider. Obviously, I mean, we often, I think, consider some solutions cost, but, you know, it's always a fine balance of making sure that you're picking the right solution, both in terms of human cost and in terms of solution cost. And then there's just some common questions that came up during the project. I think, you know, people often have questions around Druid or anything that maybe is a less traditional solution for some, especially if they're used to things like Snowflake or BigQuery. So one of the obvious questions that came up is, can we run joins on Druid? And the answer is yes, right? Like, there are options of how to run joins on Druid, both in terms of lookup tables and as well as in terms of joins that Druid does support. So that was something we were able to do as we were building it. Another one was, obviously, does this replace their current data warehouse? And in our view, we didn't view it as that. We viewed it as definitely an extension, something that provided more to what they were doing, right? Again, we kept it based off of the same data set. We didn't want to change the data sets because the big value was, hey, let's just build this off of, you know, the actual data that you're already using. So no, it didn't replace that. And then, are there any limitations from a SQL perspective? Druid doesn't necessarily have all of the functionality that maybe your standard ANSI SQL does have, but it provided enough to actually answer the questions that we were trying to answer, which tended to be more focused on grouping, aggregating, and doing some modeling in terms of like fraud detection. So everything that we needed to do was supportable in this case. And so, you know, overall, this project, I think, is a great example of finding the right solution for a very specific problem. All right, and that's it for me, guys. Thank you so much for watching. I really appreciate everyone's time here. Other than that, if you do need to find or ask me more questions, feel free to look me up at anything under Seattle Data Guy. Other than that, guys, thanks so much for your time, and I will see you guys maybe around. Thanks.